All right, guys, so one other thing that I'm going to actually add below this flip book that we have on page 69 is just a quick thing about some other proportions that we can write involving indirect measure. So when it comes to similar triangles, they can be super useful when we're trying to figure out like how tall a really tall thing is. That's the most practical use for similarity. So to figure out how tall a tall thing is, or maybe how far away something is that I can't just measure by hand, we use this thing called indirect measure. And there's kind of like sort of three different ways you can think about indirect measure. We might have like a bounce, and this bounce might like be a literal ball bouncing, like think about a pool table, or it could be light bouncing, but then there's kind of another example of that too. But either way, when I have a bounce, so imagine again like the pool table, you have a ball traveling this distance, and then when it bounces off, and then you can kind of like complete and make a triangle here, make a triangle here. But at the place that it bounced, those angles will always be congruent. And when I drop down these sides here, they are perpendicular. So you really do have angle-angle similarity here, where we can set up proportions to write relationships and solve for things that I don't know, like, you know, maybe how far the ball traveled, if I can know one distance, or like if I know along the edge of the pool table exactly where it hit, we can write that proportion compared to how far it's traveling. I'm so sorry about the bell. Another one that's kind of like a bounce, I would call more of a shadow. So like from the sun, if you're out in the sun, when the sun's shining down at a certain time, all the shadows that you cast are similar triangle shadows. So you could think of like a tree casting a shadow onto the ground, and then maybe you standing here casting a shadow on the ground. And if you kind of go to this point where the shadows meet, you really almost get a situation kind of like these triangles over here, because we have that me standing up and the tree standing tall are kind of parallel to each other, and so you can write these shadow ratios. And also you have like a right triangle here, so we got that angle similarity again. And then the last sort of indirect measure is also, I guess, sort of a bounce, because it's like light bouncing off, or a shadow again, but it's just used in a different way, where we use a mirror or a reflection. So what that might look like is kind of like the bounce picture. So like if I have a mirror placed on the ground, if I look into the mirror and I can see the top of a really tall object, like maybe a flagpole or something, the like reflected vision, I don't know how to explain it, but this right here again is a congruent angle, a lot like our bounces, like me, like the angle of my eyes looking into the mirror, and then the angle coming up from that mirror to that really tall thing, as long as I like look at it right at that height, like seeing just the very tip top of the flag in that mirror, will get you these congruent angles. And again, we have the 90s because we're standing flat on the ground, so we have similarity there as well. So we're doing like height compared to height. To figure out how tall the tall thing is, like I can know how tall I am, and I can know the distance I am from the mirror and the tall object is from the mirror. So a lot of these distances we can know so that we can figure out how tall the tall thing is. Similarly, like with the shadow one, I know how tall I am, and I can measure the length of the shadows. So shadow to shadow, and my height to the tree's height, to sort of set up those proportions there. And that's what our Desmos activity is going to be about today. So hopefully that kind of helps how I should set up those ratios.